Assalamualaikum, and I wish a very good day to our lecturer, Dr. Azli bin Nawawi. Today our group we will be presenting on our chosen product, which is a folding chair to be improved using the FMA table. My name is Rabiatul Awaliah bin Zainal. For the background of study, the demand for consumer products has risen each year, and the development in technology and growth in our industry have also impacted the market for the product. So in terms of the speed of production needs to be faster. Regarding of this issue, the ease of production is the FMA, where the final outcome will be the exact design of the production assembly line. The design for development and design for assembly have been combined to form the FMA to facilitate the process of the product design, that it will help to use all the instruments and optimize their capabilities. The design effectiveness is increased by implementing the DFMA process, and integration is facilitated when fewer active parts are used to standardization. Second, manufacturability is increased by integrating DFM methods. Third, design alternatives are tested and design instruments are used before release. Fourth, a system to align product quality with design effort and products require product and process design. So in this assessment, we need to identify a suitable product, which is we choose the folding chair, and the products need to contain 30 parts. So the folding chair is suitable because it contains of 42 parts, including the fastener. So this folding chair can be full when it not in use, which will save the space. For the problem statement, in order to attract more customers to buy our product, the product must be in low cost and good quality. So our group has planned to improve the design of the folding chair in order to reduce the production time and the production cost. So the folding chair consists of 42 parts, which makes the production time will become longer. So after some discussion among us, we have decided to redesign the folding chair using the FMA implementation. For the objective of this project, we need to evaluate the efficiency of the original product and a design product by using the manual DFA evaluation worksheet. Second, we need to compare the efficiency of the original and redesigned product in terms of assembly time, assembly cost, and design efficiency. So the scopes of this project, we will be using a folding chair as a product improvement. Second, each product parts will be disassembled and evaluated. Third, we will evaluate the original product and redesigned product using the DFA evaluation worksheet. And fourth, the original design and improved design will be compared using from the data from the DFA table.
Next, design for manufacturing and assembly, DFMA. Design approach that focus on ease of manufacture and efficiency of assembly. The FMA has traditionally been applied to sectors such as automotive and consumer product design, both of which needs to produce high-end quality products in large number in an efficient way. The FMA is used as the basis of concurrent engineering studies to provide guidance to the design team in simplifying the product structure, to reduce manufacturing and assembly costs, and to quantify improvement. The practice of applying the FMA is to identify, quantify, and eliminate waste or inefficiency in product design. Next, 5 principles are examined during a DFM. DFM stands for Design for Manufacturing. It's the process of designing parts, component, or product for ease of manufacturing with an end goal of making a better product at a lower cost. So first is process, number 2 is design, number 3 is material, number 4 for environment, and 5 is compliance or testing. There are factors that can affect design for manufacturing and design for assembly, which is first, minimize part count, number 2 is standardized part and material, number 3 is create modular assemblies, number 4 is design for efficient joining, number 5 is minimize reorientation of parts during assembly and machining, number 6 is streamline number of manufacturing operations or process, number 7 is define acceptable surface finish. Shows the folding chair that will be evaluated and improved in this project, and table shows the folding chair component and manufacturing process. Based on the table, there is the name of component, material used, quantity, and manufacturing process. So for the manufacturing process, it consists of 4 process, which is machine or cut from the stock, compound die stamping, injection molding, and also assembly fabrication.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Azul Fazli bin Muhammad Fazri. Today I would like to present project flowchart. First start, and then we identify the problem statement, objective, and the scope. After that, literature review, and then we go to the selection of product, then the assembly of the product. After that, evaluation of the original design of the product using the FA table, and then modification of the original design. If we succeed, we go to the next process. If not, we go back to the evaluation of the original design, and then evaluation of the improved design using the FA table. Then compare the design efficiency of original design and improved design. And the last one is discussion, conclusion, and recommendation. After that this is the original design of the folding chair. The part that we use is a backrest, cross brace, foot caps, and frame 1. And then for original design, we use a frame 2, and then we use seat, spreader, stability caps, and fastener. And then this is the new design for our folding chair. So we can see that we use less part than the original design. So the part modification is we use a main frame, secondary frame, seat in wireframe view showing pocket for sitting second frame, and the last one is fillet pack for location and load transmission.
Hello and Assalamualaikum. My name is Muhammad Najmi bin Norizan. So I will proceed to the next slide, which is the FA table of original design of our folding chair. The FA table is compulsory in order to do the DFMA manual analysis. So first thing first, before we complete the DFA table, we have to determine the alpha and beta for each component of the original design. So in order to determine the alpha and beta, we have to disassemble the component first, and then after the disassembly, then we can evaluate their alpha and beta. So after the alpha and beta have been determined, we will complete the table by using the value in the manual insertion worksheet and also manual handling worksheet. So for the original design, the value that we get for the operation time is 335.7 seconds, while the operation cost for the original design is 134.28 ringgit, and the estimation for theoretical minimum part is only 4, and the design efficiency of the original design is 0.036. Move on to the next slide, which is the FA table of improved design. So after some modification that we made, after some improvement that we made, the parts that we have for the improved design is only 4, whereby the first part is main frame, the second part is the secondary frame, the third part is seat, and the last one is fasteners. So basically we have to repeat the same step that we have done on completing the DFA table of original design. Then the first step that we do is to determine the alpha and beta for the component of the improved design. And then after the alpha and beta has been determined, we can complete the table. So the operation time that we get for the improved design is 38.65 seconds. The operation cost is 15.46 ringgit, and the estimation for theoretical minimum parts is 4, and the design efficiency for the improved design is 0.31. So for the comparison of data between original design and improved design, for the original design, the total assembly time is 335.7 seconds, while the improved design is 38.65 seconds. The total number of parts for the original design is 42 parts, including fasteners, while the improved design is only 5, including fasteners. The total operation cost for the original design is 134.28 ringgit, while the improved design is only 15.46 ringgit. The design efficiency for the original design is 3.6, while the improved design, the design efficiency is 31%. That's all from me. Thank you.
Next, I will proceed to the conclusion of this study. So, the design efficiency of the original design has the value of 3.6%, while the efficiency of the improved design has the value of 31%, which is much higher compared to the efficiency of original design. Next, we managed to increase the design efficiency, which is from 3.6% to 31% of the product by reducing the number of parts and also combining some parts to reduce its assembly time. After that, the total cost for the redesigned product is much lower compared to the original design, which is 15 ringgit and 45 cents compared to the original design, which is 134 ringgit and 28 cents, which is very high for a folding chair. Next, it can also be concluded that reducing the number of parts will reduce assembly costs. Last but not least, the FMA analysis help to improve the product design, and this is proven as there is a reduction in number of parts and assembly time on the products being studied. So next, we proceed to the recommendation. First, it could be changed by designing the product's design, which would give the customer a more relaxed rest position. After that, the designer may also adjust the product material, such as lighter materials and lower cost material, to reduce the cost of producing it. Last, it can also improvise by expanding the backrest into a little wider so that it ergonomic for a big size user to use in shorter and longer time. Thank you.